Biracial. No. You there, Blossom? Hello. Hello. Hello.
Hi.
Okay, great. Okay, let me turn the volume up a bit. Okay, here we go. Wait a minute.
Do you think David can win?
Wait, what? What did you say?
Do you think David can win?
David will be late, okay? He's always late.
Why you can't ask him?
Yeah, why you keep asking me?
Yeah,
Can you ask something else? Why? Okay, wait. Okay, I'm going through this today, right? Before that, I need to write down what topics you are doing now, okay? So let's start with this. What topic are you doing now? Probably a solution and suspension. Okay, I know about it.
You're doing crystallization.
Crystallization. That means separation. Actually. Okay. So, what? Mixture. So it's element composition. Ashley or Ashley? Ashley. S-H-L-E-Y. That's spelled correctly. What's your? I will ask the Ashley is sec 2 side. Wait, Ashley is from your school.
Huh? Ashley?
Yeah, it's Ashley from your school. She knows Celeste. Ashley knows Celeste.
What class?
I don't know. Sorry, Ashley. I don't know what's that. Ashley. What topic are you doing now? That's right. I don't know.
I was telling
Don't know yet, right?
I was telling you said Celeste, then you said that she said, yeah, it's Sarah, and she said, why you so tall?
Pastor, what topic are you doing now?
Classification of metal.
Oh, okay. I thought you were doing physics.
Yeah, like next week then we do physics.
Okay, got it. All right, so we are done with classification method, right? So we have David as well. He's not here. Maybe later we'll ask him, okay?
Disappear. Just right.
Yeah, wait, let me write today's data. I just need what?
Disappear. That's what disappear.
Disappeared. Today is the 3rd. Wait, what? You see how come my phone will? You get that?
Yeah.
Was it like?
Tell your password.
When you pick it up, you just go straight to that page.
No, I'm not doing anything. It just goes. And then last week I was showing.
I'm still like, okay, what?
I was showing Celeste, right? Wait, also, do you remember I showed you this
Yeah.
last week? Did I? No. Do you remember Sunday? The thing will type itself, no?
No, you're so scary.
Yeah, then I showed. Huh?
What the password?
Of course I can tell you, right? But it will type by itself. Okay, so I'll put it again. If it types by itself, I'll show you. Okay. I wanted to record it on camera because nobody believed me. So,
Put under
Yeah.
David disappear.
Alright.
Without you touching.
Yeah, without me, I will look at it and then it will be like. That's
Yeah, unlock.
That's why nobody believed, right? I was like, immediately I took it out, I can't record. Then after that, it.
Does it lock in?
This.
No, it didn't. Okay. Hey, Damien, the man. What topic? Now you're very far away. Yes. Oh, what topic do you know? Also, another one forgotten.
Because it's all
Forgotten. Forgotten. Okay. Is it any one of this? Can you see? Is it like solution, separation, element, compound, classification? Don't know or forgotten.
Yeah, Jim.
Solution. Okay, good. See? I cannot.
Wait, pass it the paper.
Oh no, never mind.
What?
You just started element.
Huh, element. How come I see we've done so many times?
Point.
Okay. You come, you try, you touch. Okay, good. Right. So today we're actually going through this one. Right. Solution and suspension. Again. Okay. One more time. It doesn't matter because the way I look at it, right? You see, you're gonna have a mid year. Right? Your mid year is going to be around.
I know mid-year.
Oh, who doesn't have mid year?
Everyone. Everyone.
Are you serious?
Yeah.
Yeah.
We only have W.
You have mid year?
We only have reflex.
You have mid year?
No.
No. Boston didn't have mid year. Exam.
Not like exam, not like SA1.
But there's WA, right? WA.
Exam, we only have this paper.
I know. Right? I know. We're going through again. Why? Because you see, Jim is doing solution and suspension. David, we repeat stuff, okay? Okay, we repeat. Right? I already said at the beginning of the year that we will repeat things again and again.
This is the worksheet that we know explosion.
Oh yeah,
No, we're not doing that.
I think the explosion.
No,
This
we're
is
not
the
doing
worksheet that he burns himself.
No, we're not doing exposure. Okay, so this is the chapter that we repeat again and again.
Okay,
Right.
this is the chapter.
I
This chapter.
already mentioned. Yeah, I already mentioned that I'll repeat stuff. Okay, because that's how we're gonna do it.
Which memorize what?
Okay, so let's jump into solution and suspension. Now, solution and suspension, listen, is a continuation from element compound mixture. Because after you study element and compound, you come to mixture. Mixture will branch out into two categories, right? You have solution and suspension. Okay, right? Hey, wait a minute. I forgot something important. I forgot to introduce David. David.
I don't know.
Right. David, where's your name? Okay, here you go. Right.
I don't know.
Yeah, because last week you were not here, right? Every one of us we already introduced everyone. Okay, so Ashley, that's Ashley over there. She's from St. Margaret. She's in Girl Guide. There, hey, friends. Okay, we are friends. Okay, Ashley is over there. Be polite, huh? You must say hi.
Messed up Chinese.
Rachel is over here, okay? Rachel is from Peihua, right? She's a what? Art counselor. In the art counselor, okay? Yeah, art club. Okay, so David, that's David.
Yeah.
David is from Bartley Secondary School. He is in NCC.
I don't know.
Okay.
Why would he come back from? Not coming.
Yeah, this Sarah again, okay? And that's Jim. And that's me. Alright. And Blossom. Dennis. Okay? Let's go back to what we did here. Alright, so this is a continuation of your mixture. Okay, element compound mixture. So before I begin, right, let's do a quick definition check. Okay, can you still remember the definition of element?
Yes.
David?
Yeah.
Of course, you come late, right? That's fine.
Late. Go home.
What do you mean go send people home?
I got
Okay, delivery. You know what? Let's do a game, right? The P5 loves this game.
Oh no.
But the P5 loves this game, okay? What, go home? No? So we'll select someone, right? This to be the favorite, right? Can you see? Blossom, are you able to see?
Yeah.
You laugh at me, right? Give me another one.
No.
Well, one, two.
Hey, Jim also
We're not missing anyone. Rachel. Okay, great. D-A-B-I-O-N. You changed it already, Davion. You changed it already, right?
Yeah.
Okay, let's choose some nice music, okay?
Think slowly.
Like so super slowly.
What's slow? Let's try Mexican.
No. Rock. Rock.
Some music.
Okay. Okay, let's go. We'll choose one person, right? Then you gotta tell us the definition of
This is not fair.
definition of. You compare someone else, right?
I got two I mixed it.
Definition of element.
Oh, look, not me actually.
Okay. Awesome. Sorry, it's not me. Okay, it's the wheel of this. Right? Can you tell us the definition of element? Awesome. What? What's the definition of
An
element?
element is a substance which cannot be broken down into two or more simpler substances by chemical means.
Oh, sorry. I pressed wrongly. Sorry, pressed wrongly. No, press wrongly. I haven't said the question yet.
Yeah, I'm saying.
Yeah, I want nice music. It's so scary.
So,
Video game.
spaceship.
What? Okay, whatever. 20 seconds. Okay. All right. So next question, of course, must be compound. Okay.
No.
Definition of compound.
I bet you it's a gym.
Why is it Jimmy?
Hey, come on down to your name.
Whatever.
No,
Compound.
not me. Good.
Okay.
It's not spaceship.
Yay. Do you know? Compound.
One, two or more.
Different.
Can
Very good, right? Two or more different elements can be combined. Very
Smarter
good.
than my science teacher.
What? What do you say?
Smarter than my science teacher.
Okay, we'll do the next one, right? Next one, of course, is the definition of element. Mixture. Mixture. Okay, ready? Definition of mixture. Ready? Let's go. No. Oh, no, awesome.
Okay.
Okay. You know why? She's always chosen because she knows, right? Yes. She knows, huh? Is that bias? The real bias, okay. Another Rachel. No bias. You have to follow energy, okay?
Hey, hello, I'm 3 minutes.
Okay, great. Now it's smaller. The pie is smaller now. Okay, don't worry. Yeah, who wants more?
You.
Me? No, I don't know.
Everyone's name 2 times.
Hey,
mine got 3. No. Mine got 3.
No, those who make the most noise, I add some more. Alright, okay, wait, bottom. It's not noise. I'm not making noise, okay? Okay, Blossom, come on, don't worry. She knows, right? Okay, what's the definition of mixture?
Mixture is a substance that consists of a mixture consists of two or more substances that are not chemically combined together.
Very good. Okay, not chemical combined. Okay, very good. Next question is give me an example of a mixture. What? Example of mixture.
Not me. Oh, it's gonna be me. No, it's me. No.
James. Yeah. Yes. Example of mixture. Air. Oh, very good. Give me another example of mixture. Cannot use air. Another example. Not you lah.
Can it be like a chemical?
Example.
Can I do like a chemical name?
What?
Like chemical name.
Chemical name?
Yeah.
What chemical name?
Like,
Wait. My question is, give me an example of a mixture.
H2SO4.
Wrong. Wrong. That's not example of mixture. That's H2SO4 is a compound. Milo, very good. Okay. Do you understand? Milo is a mixture. Do you know why? Because two or more different things, they are put together, but they're not chemically combined. Milo powder. Yeah, mild water actually also can, right? They're not. There's no chemical reaction. You understand? They're just put together, right? But no chemical reaction. Okay, David, what are you doing, David? Don't tear. Why are you tearing my pencil apart? Huh?
I'm helping you.
No, no, no.
I'm helping you.
Okay, next, give me an example of a compound. No, give me two examples of compound. Okay, two examples of compound. Alright, ready?
No, not really.
What?
There is a real bias.
Oh, real bias. Yeah, the real like to choose green color. I don't know why, right? Like green color cannot very
I
effective.
can change my one to black.
How to change? I don't know how to change. Alright, so two examples of compound. And what? Don't be. See, green color bias. Okay, example. Yeah, we will bias. Okay, too bad. No, no, no. Give me two examples of compound. Two examples of compound.
What do you drink every day, man? What do you do?
What do you? Water, yeah. H2O is an example of compound. Right? Another one, give me another one.
Your salt.
Your what?
The salt that you eat.
The salt. What is the salt?
What's the name, huh?
What's the chemical formula? What? What? Sorry?
The one you use to cook.
Yeah, yeah.
That was the name.
Do you know? Do you know? Do you know? Do you know? Sodium chloride. NaCl. Wow. So far, who haven't gonna?
You. Me.
Okay, we're gonna remove all those that gonna many times already. Okay, because it's so. Blossom. Rachel on it.
What's that called? Rachel? I mean, actually, haven't con.
What?
Wait. I still got two of my.
Yeah,
my
of course
shirts.
that's right. You haven't gonna. You got three.
Wait, I already cannot before. But
Did you?
I went.
I also got one too. I got one.
And then one. Okay, so. Oh.
Hey!
Yes, finally the wheel is clear right now. Okay.
It's
No more bias. No more bias. No more bias. Okay. The question is, name the four types of materials.
materials.
Yeah.
Anyway.
Classification of metal. We did that last week, right?
Really?
The four materials.
Oh,
David not
metal.
here. David not here.
Metal.
Metal.
Styrofoam. Wait, what?
No.
Plastic.
Plastic.
Glass.
Glass.
Ceramic.
Yeah. There's another one that's F. That's F.
Chlorine.
Clothing. Fiber. Yeah. Very good.
Fluorine.
No, fluorine. Okay, done, right? So let's come back to here. That was a quick introduction. I lucky.
Yeah. Do that. We keep going.
Then I have to keep asking you.
Add yourself like 4 more times.
It is not fair. You put 3 for me.
Yeah, you love it. Okay, come on, let's continue, right? Alright, so under mixture, mixture, we have solution and suspension. Right? So today we'll study about what's the difference between these two types of stuff. Okay. So what is a solution now? The picture is quite bad actually. So definition time again. You see, a solution is formed when a solute dissolves in a solvent. Now the best way to study this, right, is actually to look at an example. So salt water. Salt water.
That's a company.
Look at that, right? Look at that. This thing, right? Salt water is an example of a solution.
I didn't know the water can be so salty.
Yeah, I know.
Huh? What? Salt water is a solution. Why? Now look at this definition. A solute plus a solvent equals to solution. So what is the solute? You see, the solute is either the sugar or the salt, right? Dissolve in solvent. Solvent is the water, right? So you put the salt. This is the solute. Put inside here. This is called a solvent. You get a solution. Okay, solution. And what's next? Oh, okay, we drew a lot of stuff. All right. So where did the salt go to? where did the salt go to when it goes in? So obviously, you see, after we dissolve, right, we don't really see the, when we,
Wow.
oh, Boston watching movie, is it? Watching movie. It's caught,
Expose
right? Expose it. Okay, so you see this where does the salt go to when it's dissolved?
Coronavirus researchers.
Where does it go?
Water particles.
Okay, in between the water particle. So this blue color are actually all the water particle, right? And the black color dots, right, are the salt particle. So when you put this solute into the water and you start stirring, they break down into tiny particles and they get in between the water particles, so you don't see them anymore. So one characteristic of solution is that the whole thing is very clear, right? You can see that it's clear, and there's no that you don't see anything like lying around or residue that's undissolved at the bottom. Okay, you don't see any of that, right? So that is definition of a solution. Okay, so there are many examples. Here you see some solutions are colors like sugar, salt, acid, vinegar, alkali. Right, some are colored like copper sulfate solution. Let me just show you copper sulfate. Yeah, I always remember this. You know why?
We know you're doing experiment next year of crystallization.
Okay, yeah, so you will use this to do crystallization experiment. So this is a solution, right? Why? Because after you put the copper sulfate powder inside there and you fully dissolve them, it just looks like a clear blue solution.
No, suspension is like when the thing that floats.
Floats. Oh yeah, that's a suspension. Okay, so this is called a solution. Next, wait. So because to study solution, this chapter you need to understand solubility. So definition number 2. Later we test, okay? Solubility is the ability of a given amount of substance to be dissolved in a unit volume of solvent at a given temperature.
Can you remove my name? That was 3 times. That's very unfair.
Alright, so solubility is the ability of a given amount of substance to be dissolved in a unit volume of solvent at a given temperature. Okay, so actually it's a lot of common sense. When we say something is soluble, or we say that this solubility is very high, basically we just mean that a lot of that thing can dissolve in the liquid at a given temperature. It's a lot of common sense, right? It's just that they want to word it in a scientific form. Okay. Now here's another point that you need to remember. Right, factors affecting solubility: the type of solute, the temperature, and the type of solvent. Now let's talk about the type of solute first. So for example, sugar will dissolve in water better than chalk. If you take chalk, you can't dissolve in water. When we talk about this, right? Kopi o gao, what's this? Thick kopi o, coffee. Thick coffee. Now, old people like to drink hot water, hot tea. Huh? What? What did you say? Oh, I thought what? I'm talking about old people. You tell me 1 hour. 1 hour. I don't want to talk about.
Everyone drink.
Yeah, we want everyone drink hot water. Okay, never mind. Right? So the temperature of the solvent. Now, as long as the temperature is high, more of the thing will dissolve. So, example, the old folks, right? They love to drink super hot water. Some of that is so hot, right? It's like scalding, boiling water. They can just drink that one. No, you just seen before.
The thing is cold water.
Magic tongue. Tongue of steel. Magic lips, right? They can like that was like, wow, so hot. You can also drink. Huh? They can't sense the They can't sense the temperature.
I think they lost their sense of taste in the time.
I think it's none of all those reasons. Okay,
They
just okay. Why they like to drink hot water? The reason very simple. It's because when the temperature is very high, you can dissolve twice as much sugar, and you can dissolve twice as much of the coffee powder in 1 cup. But they need that, you see, they need the.
They need it, but then they cannot resist it. Like,
Yeah, they can, right? They need the like coffee, like you know, all the coffee going in the brain, all this too. Yeah, exactly. I don't know, but they are used to it already. They used to it. That's all. Come on. Okay. All right. So the temperature of the solvent will affect the amount of solute that dissolves inside. Next, the type of solvent. Come on. The type of solvent. Type of solvent means that, for example, iodine can dissolve in alcohol. Hey, someone don't throw. That's noisy. Okay, so iodine can dissolve in alcohol better than in water. So another example is blood, right? You know what's the best way to wash blood? Let's say you have some stain.
water your blood.
No,
Water your blood.
no.
You drink the blood. Soak the blood.
Clothing. Coke, no. Okay, what type of solvent? You can't use water. Water will. It's not good enough. Okay. Yeah. No. Dettol, no.
No, it's stuck.
Best way to remove
Vinegar.
vinegar? No.
Oil.
No.
Oil.
It's salt water.
Oh.
Okay.
So you just dip it inside the ocean now.
Yeah. For example, right, glass stain of clothing, right, you can't remove it there'll still be like a bit of it, right? But if you use salt water, all the blood stain will dissolve, right? So this is what I mean by the type of solvent.
So that means you keep your blood.
No, we don't kill people, okay? We're just saying in case you have like a bit of blood on your clothing. Huh? Yeah, you get evidence. Into the sea. Okay, next, the rate of solubility increases when, obviously, when the temperature is increased, right? Things will dissolve faster. Solute is broken into tiny pieces, right? It will dissolve faster as well. And if the mixture is stirred well, right? If you stir the thing rigorously. Okay, so the next thing that we talk about is the opposite of solution. So the opposite of solution is called suspension. What is suspension? It's when you have lumps or solid or liquid particles that are insoluble and are suspended in the liquid or gas. Alright, that's what we call a suspension. So the best example I can give you is Milo dinosaur or even bubble tea.
Godzilla.
Milo Godzilla.
Godzilla versus Kong was a boring show.
Really? Huh?
Could you like
What?
I am
This one, Who are you? I'm you but stronger. Yeah. Really? What's the difference between dinosaur and I thought we talked about that before. Really? Milo King Kong. What?
Such a Milo Godzilla versus Milo Dinosaur.
Yeah.
Ice cream.
Yeah, this one got ice cream, right? Godzilla got ice cream, dinosaur no ice cream.
Wait, such a dinosaur versus Godzilla.
Yeah, correct. There you go.
No, like the actual animal.
Wait a minute. Let's talk about science, okay? So here, now this is called suspension. Now why? Because this stuff cannot dissolve anymore. Okay? That means that if you dissolve something until it's totally saturated and you can't dissolve anymore, we call it a suspension. Okay, so it's called suspension. So this is one good example. Okay, you can't really dissolve all these things anymore. Right? So in a suspension, what happens is if you go and filter the suspension, you're going to get the residue, the powder, the dinosaur will be stuck here. Okay, then the rest of the Milo will go down.
The dinosaur.
Yeah, the Godzilla and the dinosaur will be stuck here. The rest of the stuff goes out. So likewise for bubble tea. You see, bubble tea is a suspension. Bubble tea. Ooh, look at that. That's fake. That's a cake.
$198.
That's a cake, right? Well,
the hell is so expensive one?
yeah, this is a suspension. Okay, why is it suspension? Because you can see clearly the pearls are suspended there.
Why the bubble tea look so fake one?
Yeah, please, help yourself, okay?
I'm dying.
We don't want you to, we don't want to carry you. Right, so you see suspension, right? All these
The
are
bubble tea
suspension.
one look so fake one.
So this is like the classic example of the suspension, right? Like even the sugar is suspended.
No, the right. The left. Left.
Uh,
I want to see the bottom.
Koi, this one.
That's Gongcha.
Bubble tea is bad for your health. Yeah, it's true, right? Bubble tea is bad for your health. Don't drink so much every time.
I haven't drank any this 2 months.
Last time I used to have a student who comes with bubble tea every lesson. He has to drink one every day. No, he doesn't have diabetes.
My friend gonna get diabetes for
Right? He has to drink one every day. Those were the days of the Gongcha. Gongcha. I said every day must go and find one, buy one Gongcha. Huh? Oh,
My friend is weird.
expensive.
Black caramel milk tea 120% sugar.
120.
You.
100.
Caramel milk tea.
Too much sugar, right?
Ah.
Okay, so all these are examples of suspension, right?
Go to the right. Yeah, that is the best bread.
This one?
No, the one
No,
there.
yes.
Are you sure what is this?
This is damn good. Remember we bought it together?
What?
No, this is disgusting. No,
What
I
is
think
this?
they say it's the phone was like right. Sure, you can find the jewel.
Really? This one jewel?
Wait, where did we go?
Wait, you mean all of you know about this?
We went to
You know about this?
We went to like
we went to
City Square, is it? It's near my house.
Why is this better than others?
Cause this one is real tea leaf.
Which one is
And
fake
it's
tea?
like not so sweet so. This one is the bitter version of tea.
Or the bitter tea, yeah. Alright, okay. So good to know, huh? 吃茶三千.
I'm not around one.
Yeah, why?
We all like this.
Convenient. Liho is convenient.
Yeah, it's convenient. It's like what right across.
Yeah.
Yeah, go village and go.
Okay.
Alright.
Alright. Okay, so anyway, so you know the difference between solution and suspension, alright? So another way to tell whether something is a suspension is if you give it some time to stand, right? That means you leave it there for a while. If you see insoluble particles that settle at the bottom, then it is called a suspension as well. Okay. So when you stir it, the whole suspension becomes cloudy. So examples: cough mixture, seawater with sand, and vegetable soup. Okay. Cough mixture. Now, why is cough mixture a suspension? Cough mixture. Okay, this time, huh? Yeah, if you leave it for a while, a lot of the stuff will settle at the bottom, right? You actually have to shake. You gotta shake the thing. What you can say? Powder. What? This one. How to spell?
PRO. M.
Promethazine.
Disgusting.
Yeah, the green color one. Yeah.
I hate it when the doctor gives me that.
Yeah.
Mr. Ong, Mr. Doctor Eugene Ong.
Ong?
Yeah.
Okay.
Look.
That's a suspension. Okay, so all these are suspension because how do you test? You leave it there for a while, right? It will settle. The particles will settle. Okay, and you get they don't dissolve, right? Vegetables obviously, okay, the tofu and the vegetable, they don't dissolve. If you can make a thing dissolve, you're quite weird, okay?
Because there's a teacher in my school for Eugene.
Yeah, they don't dissolve, right? So all these don't dissolve.
Why are you counting down the time?
Yeah. Okay, so that is solution and suspension. Now under solution, okay, we have two other types again. We have acids and alkali.
I remember you asked me.
Yeah, acid and alkali. So under solution,
this is when they
Yeah.
burn themselves.
Yeah. That's not dash.
Okay, do you have this? Can I check that your notes have this thing? Yeah, right. Okay. So acids and alkali. This under solution, okay, under the classification of solution. So because acids and alkalis, they are solutions. They are clear liquids, right? Most of them. So we gotta understand all about that, right? So let's start with acids first. So acids we have two types, right? So we have the edible one, and then we have the lab. So there's edible, and then there's the lab. So examples of acids in our everyday life: lemon, okay, vinegar, soft drink, yogurt, these things, stomach, right? Stomach produces hydrochloric acid, which is used to kill bacteria, not humans. Okay, kill bacteria. So the hydrochloric acid kill bacteria in the stomach. Car batteries, all these they are sour. Right, the characteristic of acid is that they are all very sour. Like for example, lemon, of course we know. Vinegar, of course we know. Now soft drinks we don't know. How come we don't taste the sourness in soft drinks? When we drink, yeah, when we drink Coke, right? We don't taste any what do you call it, carbonic acid. Yeah, the reason is very simple because they add the reason why they had to add so much sugar is because they need to cover the sourness. Why do they need to put so much acid inside there? To produce the fizziness, the carbonated effect. Okay, so to do that, they need to put a lot of acid. And after they put a lot of acid, they realize that nobody's going to drink this stuff, huh? So we better put a lot of sugar, right? So they pour like 7 teaspoons of sugar into one can. Huh? Entire bag of sugar, they can't, then it becomes too sweet. Okay? Yeah. Yeah, so almost like I think there's like some kind of someone actually did some kind of experiment like how much sugar is there in Coke in can of Coke, right? It's like 1/3 the yeah.
Holy shit, go buy some.
Yeah, see this one, right? So you see this cup, this can has got this
What's the next key?
right. These are ice lemon tea.
Oh.
Ice lemon tea, okay? So Red Bull is still not so much, right? Coke is the worst, right? They have a lot.
That was the one next to Red Bull.
This one, orange juice.
Brown sugar like milk tea.
Hey, see this one is the best, zero.
Water, sure got zero.
Nothing. Water is nothing, right? What is this?
What is
Milk.
Some
kind of milk. Oh, I don't have, right? So this one is the worst, right? Followed by this. So don't think you drink ice lemon tea, what else? Green tea, all these are very healthy. Garbage tea? No, they didn't do a comparison like that. Okay, but generally it's like this. Generally, so you see, you need to put so much sugar to mask the sourness. If not, nobody will drink it.
No, the bitterness of the tea.
No, I'm talking about the soft drink, right? So that's the amount. Okay, when you drink one can of this, it's like eating one bag of this thing. Do you eat one bag of this?
You can just eat it.
Yeah, but do you eat the one bag of this?
No, I don't drink Coke.
You don't drink
You're
Coke?
not allowed to drink Coke.
Huh?
The last time I drank Coke was 3 years ago.
What do you mean you're not allowed to drink Coke?
Like I'm banned from drinking Coke.
You are bad. That's your family, right?
Yeah, so I can't drink Coke at all.
Yeah.
The last time I drank was 3 years ago.
Yeah, that's how bad it is.
And
Okay.
my dad bought like a bit just to drink.
A bit just.
But he bought one can. Then I
So
drank
that.
then I drank half of it.
Yeah, this is a bit. Alright, so it's a little too much, you see? It's too much sugar inside there. Alright, anyway, that's to mask the sourness, okay? Okay, so here comes the part where you need to memorize stuff, okay? So these are the lab acids, laboratory acids. We have 3 of them, right? Hydrochloric acid, sulfuric acid, and nitric acid. So this the first one is hydrochloric acid. Second one here is H2SO4 is sulfuric acid, and the third one is HNO3. Now we're gonna take 2 minutes of your time to memorize it. Okay, I'm gonna ask you what is hydrochloric acid. Then I wrote here HCl. Chlorine is Cl. Okay, so small letter L. J is like that. L is like that.
No, how is L like? Yeah.
This is 1.
The red level.
What?
Red level.
Right level?
There? L what?
What?
L say what?
Yeah, okay. Okay. Right, so can you memorize this now?
What? Oh, what?
Memorize this now. HCl.
Yeah,
Yeah,
Yeah, don't worry, later we'll play the game, okay?
No.
So you can
Can
memorize.
we change the music first?
Yeah, sure.
Yeah, I'm a bit weird.
Relaxing, huh? What? Okay, come, 5 minutes, memorize this.
5 minutes is
Not enough.
Okay, 2 minutes, come.
Not enough too.
Hydrochloric
You
acid,
need 1 hour to memorize this.
what?
sulfuric acid, H2SO4. It won't be lah. What? Okay, we shuffle, you see? Shuffle.
Wait, so we're you're not gonna add back the others?
Yeah, of course I'm gonna add.
So Skype's still remaining at 3.
No, nah, it's
Wait,
bad.
Really, I'm green.
Then shuffle already. No more.
Wait, why is still?
Yeah, you shuffle it this. That's what I mean.
Okay, who else that?
Wait, you know,
Shuffle.
wait. Yeah, I have an unfair chance, you know.
What do you mean?
My names are right next to each other. That makes the thing even worse.
No problem. Remove up.
I'll solve. No. It's next to each other too.
Wait, why is it always need to shuffle then? Yeah, already. Good. You got the green now.
No.
David. What? Wait, David wrong. Huh?
No, it's Dabayon.
A-N, right?
No, IOM.
Correct? David.
I request for IOM.
Ready?
Can I have IOM?
Are you ready?
Just put empty.
It was BIOM.
Are you ready?
No,
Yeah.
I haven't had anything.
Start now.
I think the only thing that's going to remember is HCl.
Sulfuric acid H2SO4 because sulfuric, right? That's sulfur. Sulfur. And then this nitric acid, okay? So N, there's a letter N. N, so it's nitric, right? Just remember all acids, right, has got the letter H in front. H. Okay. So why you need to memorize this is because in the science lab, right, there'll be in bottles like that. They're all colorless. They all look the same. So you got the only way you can tell the difference is by the label, which is HCl, H2SO4, HNO3. Okay. Okay, 1 more minute.
No. Tomorrow 1 more minute.
Yeah.
Remember all 3?
Yeah.
I don't want.
You cannot go on. You're in the game.
I'll just die then. No, we just say I don't know.
I don't know.
But you will know.
Are you sure?
Yes.
H2SO4 is
Okay, ready?
S.
Okay, very good.
This one also test the next one.
Yeah, quickly. Still got the alkaline. Still got the alkaline. Are you ready?
Take a 40 minutes.
41 minutes.
Ashley, are you ready?
Yes. It's really only 1 minute.
David, are you ready? Oh, David is done. Okay, Blossom, are you ready?
Yeah.
Yay! Okay, here we go. Okay, as long as half are done, we're ready to go. Okay, so we're gonna test the
You have to test everyone.
chemical formulas. Wait,
You have to test everyone. That's how you test everyone.
don't have time to test. See, happy music. Hey, Ashley. No, Rachel. I try my best, okay? I already removed. You see, you only have one instance. There's only one of that. Jim has 2. Sarah has 2. Sarah has 3. No, Sarah 2.
That's why you put 3.
Oh, I have 3. I don't know, but it's destined, right? You're destined to get it. Never mind. I give you the easiest one, okay? What is hydrochloric acid? Chemical formula? Yeah. Ah, very good. Okay. Change music. Lobby. FBB. Okay, next one. Let's go. Hey. Oh, science essay.
Yes, I have been calling that.
Yes. Okay. Okay, actually, what is nitric acid chemical formula? Nitric. What? HNO? Say again. HNO? 3. Yeah. See, you're all well prepared. Okay. Last one. Last one, we'll do all 3. Okay.
If it's me,
Oh, man.
aha,
Oh, no, it's me.
Today.
Yes, it's me. Done. Well, yeah, H2SO4 sulfur acid, right? HCl hydrochloric acid, and HNO3 is nitric acid. Here you go. Yeah, HNO3. Okay. Don't worry, I no sweat over this. I've done this like so many times. Okay, so that's the 3 chemical formulas. Yeah. Okay, so what's the reaction? What's the behavior, right, of this chemical? So you need to know that as well. So this was the one where Davian
Burn
himself. Okay. We have time. We have time. Yeah. Where's the video? I don't know.
Wait, you have the video?
Yeah, the video.
You posted it.
I don't know where it went. Okay. I will.
Wait.
I'll go and find it. Okay, so here, no. So here, if you take acid, you plus metal. That means acid means if you take either nitric acid or hydrochloric acid or sulfuric acid, right? You add metal inside, you're gonna get hydrogen gas. So this hydrogen gas will actually cause a pop sound. Okay, it's a pop sound. Yeah, sounds exactly like that. Okay, so this is one of the reactions. So these are the chemical stuff that you know. Right, so how will they test you? They'll test you like, oh, if you take acid plus metal, what are you gonna get? So you're gonna say, oh, you're gonna get a salt plus hydrogen gas. Okay. So another example of a chemical reaction is if you take acid plus carbonate. So what's a carbonate? Carbonate is any chemical with carbonate. Like for example, sodium. For example, sodium carbonate. Okay, example. So if you take sodium carbonate, you add it with an acid, you're gonna get a salt plus carbon dioxide gas. Okay. Last but not least is the alkali plus acid reaction. You take acid plus alkali, you get salt and water. Okay, can we lower the temperature a bit? It's like a bit warm. Yeah, just right. Salt plus water. Salt plus water. Okay, this is known as the neutralization reaction. Right? What do you mean by neutralization? You see over here, acid is sour, right? Alkali is actually bitter. So you add the two together, they cancel each other. They cancel each other. And you get salt and water. Okay, next one. All right, so the opposite of this acids, right, are alkalis. Right? So we know that acids taste sour, alkalis actually taste bitter. And you definitely do not want to try to taste them in the lab.
But toothpaste,
No.
Toothpaste is not sour.
Because they put mint, they put like some stuff inside, right? So it doesn't taste so bitter.
You should give them the converted coffee. Actually, I have it now.
Okay. Okay, so examples of alkalis in our everyday life. Remember, just like acids, right? Is fizzy drinks and stuff like that. Alright, so alkalis in our everyday life are kind of the opposite, right? They are in the household cleaners, they are in soaps, they are in detergents, right? They are in the indigestion tablets. So if you have ever accidentally tasted your soap or your shampoo before, when you detergent, but why would you accidentally taste detergent? Oh man. Detergent. How is this mouthwash? How is this mouthwash? Which one? Dynamo? Which one? Which one is the mouth? Oh, you put something like that, is it? Oh no. Alright, yeah, that can be fatal one, alright? You must you cannot no mouthwash gargle gargle. You gargle and then you spit it out. Oh, lucky you spit it out. So how did it feel? It felt like some weird thing, is it? CA? Did bubbles come up when you were talking? The bubble? Yeah, right, so that's dangerous, okay? Right, so those are alkalites. Maybe holiday. Okay, so alkalis can be corrosive as well. Okay, they can burn your skin, especially those very strong cleaners. Have you ever handled very strong cleaning chemicals before?
Like what?
Strong. Yeah, all this, right? These are what we call the industrial kind of cleaning equipment. Right? They are corrosive one, but they'll clean everything. That means there could be stuff that is like super stubborn stains.
32 more minutes.
Super stubborn stains, right?
Okay, y'all need to start counting the time down.
Super stubborn stains, right? If you go and buy this what? Which one? Yeah? Row 3? This? Second row? This one? Which one is the third picture? I don't count from left to right. 1, 2, 3. This one lah. I don't know. What's this? Vinegar. It works, right? I don't know. Green, clover, green. Alright, so these are very strong cleaning equipment. Now, strong cleaning chemicals, right? They can burn your hands as well. So people have to wear gloves. Okay, when they are handling this, you gotta wear gloves like that. Okay. Yeah, you gotta wear gloves when they're handling chemicals. Okay, because they're so strong, they will basically what's happening is that they are neutralizing the acid. Okay, the alkali is like overcoming the acid and they're cancelling out each other. Right. So yeah, here comes the memorization part. Okay, and this is the part where a lot of students they find some difficulty. Now you see. So what are the three of them? Sodium hydroxide, calcium hydroxide, and aqueous ammonia. What alkali subject? Alkali, not alkalis. Alkali, alright? What now? This? No, this is sodium. This is hydroxide. So for alkali, all of them has got the hydroxide and this guy. This guy also has, but we call it aqueous ammonia, okay? So calcium hydroxide, now take note there's a 2 over here. So it's CaOH bracket 2. Then ammonia, because ammonia is NH4 with a OH. Okay, so same thing, 5 minutes, memorize this now. 2 much, 3 minutes. Oh no. Sodium. It says now. Now. No. Not no. Now.
You take away the A.
Okay, but the A is there, right? So it's now. Okay, calcium hydroxide, sodium hydroxide, aqueous ammonia, right? You need to know the chemical formula. Yeah, I'll shuffle 3 more times.
I want you to do my list 3 times.
What? Okay lah. So.
Put 3 times. put my name 3 times.
Really? You wanna? Okay.
4 times.
Sarah getting coffee.
Yeah.
Yeah, call it all 3 times.
Oh yeah. Hold time.
Yay!
Change. Duplicate. Oh, spin slowly. Oh, after
Spin
second.
slowly, please.
Oh. Okay, all that.
And put it for 60 seconds. Wow, don't put any 4 times. You do it at 60 seconds, then roll 29 times.
Okay.
Roll 29 times, please.
Roll it 9 times.
And put it at 60 seconds.
Ready? Concentrate. What do you mean? You concentrate.
10 more minutes.
Come on. You haven't flipped a single page. Because it's on your head already. Then,
Can you give 10 more minutes?
yeah. Two.
I remember she called you, I put no go. Remember when I said like now go?
Yeah.
I created that. You copy me.
No, it helped me remember. So you show me 60 minutes.
Finish? Okay. Actually, okay. All right. Both of you done?
Yeah.
Yeah. Okay. Ready to go. Let's go. So we will do the alkali. Okay. Wait, what is the three again? Sodium hydroxide. We should put Debian 2 times.
Okay, one more.
You never gonna anything.
Yeah.
I cannot already. Another.
The gym also was broken. Giving to yourself.
It was a true. Y'all want slow, y'all want multiple. Okay, do one more time. Hey, this is too slow. What is again? Okay, bear.
Not me.
What is it? Even with you so many times. Yeah, I think you just wrote my name. I know all the answers. Waste time. Go.
I don't know, even like 5 minutes.
Wait, what's going on?
Hi, Jane.
The last one has to look up here.
Yeah, Jane. Okay, so then other side, Jane.
Not
Jane.
slower, but.
You don't like add another one. Okay. Okay, thanks. You can study. That was so cool. Look at that. That was so cool. How did that happen? Okay, so then other side, but she knows. NaOH, very good. Okay, let's remove the. Yeah. It's our friend, the one Finally, David, right? Calcium hydroxide, calcium hydroxide. Yeah. Ah, he put effort. He put effort. Right. Yeah. Put effort, right? Okay, last one, 2 or 3. So many things. Still never cannot do.
Yeah, okay.
The more you add, the less the time there is.
We gotta get Jim, right?
Yeah,
Yeah, so then outside. NA, I'll help you. Yeah. NA, first one is NA, OH, okay? Second one. Yeah. CA, calcium hydroxide, CA, OH, bracket 2. Okay, yeah, then
Wait, what's bracket?
yeah.
What's the bracket
Then the
for?
what bracket must good right? The last one.
What's bracket for?
Last one. Equal ammonia.
NH for OH.
Well done. Okay, so we remove Sarah. Yay. You see, next question left with these people. Okay. Huh? No worry. We removed a lot already. Yeah, but if really cannot, then that's it. I don't know what to say. Okay, so 2 reactions, right? Alkali plus ammonium salt, you get salt and ammonia gas, and same thing. This is a neutralization. This is our normal neutralization reaction. Okay, so only 2 reactions for alkali. Okay, so how do you test for this? We use this lighter spleen. Okay, this is the one where we did the experiment. Right, there's also a pH or indicator to test. Right, so in acid, right, there's this litmus that will turn red color, and then the litmus will turn blue if it's in alkaline. So in acid, litmus is red. In alkali, the litmus is blue. Okay, all this usually they'll give you the table. Now there's also this thing called the pH scale. What is the scale? So scale will tell you the whether it's acidic or alkaline. So between 1 to 6, right? If the thing shows 1 to 6, that means it is acidic. If it is from 8 to 14, that means it's alkaline, and neutral is 7. So basically neutral is like water. So water is like over here. Right? I think the other chart shows the stuff, right? Oh, no, don't have. Okay, so water is here. Then your hydrochloric acid is like here. And your toothpaste and detergent is like over here. So this is just a scale. It is a set of numbers to describe how acidic or how alkaline something is. Okay. This is part where we talk about alkaline water, right? Remember we said alkaline water. Some people drink alkaline water. Right, you might recognize this. Okay. It's not mineral. It's alkaline water. I know this is mineral water, right? But this is alkaline water. Yeah, some people believe in drinking alkaline water so much that they actually install this kind of stuff, so that you can even bathe alkaline water. You bathe alkaline water, you drink alkaline water.
For one case, not.
Why? Now, why do people do that? It's because they believe that the food that we eat is very acidic. You eat. It's not super dangerous. There's a bit of science, right? But I don't know. I don't know if it's true or not. Nobody knows whether it's true or not. But they just prefer to drink it. Okay, so you see, there's this. Yeah, $2,000, right? No, this is you can buy it in NTUC, right? It's very common, right? So people drink this. Why do they do that? Because they believe that too much acid in the in the body is bad for the body. So they want to counteract the acid. Yeah.
3 legs brand, right?
Huh?
3 legs.
Yeah, the 3-legged brand thing. 3-legged. Cooling. Do you say cooling water or cooling? Yeah, this one, right? Cooling water.
I drink so much of that.
Yeah, so this is supposed to be alkaline, right? So heaty in Chinese, right? They say very heaty. Heaty means what? Acidic. Acidic cause ulcers, right? Why cause ulcers? Because acid corrode the skin. Your whole mouth is like corroded, so you get a lot of this ulcer. So when you drink all this stuff, it neutralizes the acid. Neutralize really no more heatiness. You understand? Lazada. Yeah, 390 or 6 packs, right?
That's not even the last one. That's like the first one.
Okay, so neutralization happens when you take acid plus alkali, you get your salt and water, right? That's why we drink this one. You neutralize the acid, right? So you don't get the acid. Okay, so we're done. So we got all the answers. Okay. Can you try? Yeah. No. Can you try now? Try now. Okay, which of the following mixture is homogeneous? So what's the meaning of homogeneous? That means the color is the same throughout. Right? Some of you may be wondering, like, how come air is a mixture? Okay, air is a mixture because it has oxygen coming outside, hydrogen gas, and all sorts of gases. Yeah, it doesn't explode. But you look, can you see air? You can't see air, right? It's transparent and it's homogeneous. What's the meaning of homogeneous? That means you don't get like, suddenly black color here and then brown color there. And the whole thing is the same color, which is colorless.
I can see air though.
Oh.
I just can.
Okay.
Cold air.
Cold air. Okay.
There's
There's no cold air. There's mist. Mist. You're looking at mist. You're not looking at air. No, you're looking at the mist.
I remember my mouth cannot frozen.
Yeah, mist. Okay, so next one, which of these is correct? So A again. Solute plus solvent equals to solution. That's our definition. Okay, next one, which of these would cause a substance to dissolve faster? So C, all of them. If you stir it, you use less. So wait. C, sorry, not all of them. Stirring and using warmer solvent, right? Next one, to test the solution is saturated or not, you add more solvent. Now, what do you mean by add more solvent? Because if it's saturated, that means it cannot dissolve anymore. Alright, so when you add more solvent and you realize that a lot of them are not dissolving, they are all coming down to the bottom of the flask, it means that it is saturated. And the definition of saturated basically means no more solute can dissolve. Okay, next one. Right, so the graph shows the solubility curves with temperature of 4 different substances. Which one is the most soluble at temperatures below 20? So we look at 20 degrees Celsius and we found that C is the one with the most amount of solute dissolved, right? Next. Okay, next. So we have 4 beakers with sodium chloride. So sodium chloride is a common salt. At the bottom are shown below. Each beaker is left undisturbed for a week. In which beaker would the sodium chloride dissolve first? So the answer is B. Why? Because here you have the small crystals, right? Not large crystals. Remember, if they are smaller pieces, they will dissolve faster. And then we have more water over here as well, right? Here is less water. Okay, 7. Which one are the same throughout? Which in a homogeneous, which of the following are the same throughout, right? The physical bond is same, density same. Color says the chemical bond is same, right? Just like air. It's the same, everything is the same. Next one. Right, in which one is the most concentrated? So 1 TM cube equals 100 TM cube. When we say concentrated, it means you have the most amount of solute dissolved inside. Okay, so you can do a division, or you can change all of them to 1000 cm cube so that you can measure the amount, how many grams are there in 1000 cm cube. Okay, so here, which is the best overall solvent? So it's P. Why? Because P can dissolve all sorts of stuff generally. Okay, You see, you can dissolve 14 grams of A, 31 grams of B, 12 grams of C, 10 grams of D. So generally, this is like the best. Okay. Next one, which solvent would you use if D was staining your clothes? So if D, you look at the one that has got the highest number, which is here 11. So we use S because S can dissolve the most of D. Alright, which one are insoluble to which solvent? So insoluble means you look at the zero. You see here 0 and here 0 as well. So basically A and C cannot dissolve in Q. That's what I mean. Okay. Just reading the table. Right? Yeah, that's minus C. Okay, next one is acids and alkali, right? So vinegar is actually water plus ethanoic acid. Now I didn't go through this, so I basically gave you the answer. Right? Iodine, alcohol plus iodine. Wine is water plus alcohol. So these are all mixtures. Seawater is basically water plus salt, and fruit juice is water plus citric acid. Okay, all these are the mixtures. Right? These are all some of them are suspension. Okay, like seawater, fruit juice. Wine mostly solution, but some of them are actually suspension as well. Okay. Okay, here's some more. So classify by putting them in the correct column. Solid solutions, bronze and steel. Now, why are bronze and steel solid? Because they are a mixture, right? These are actually alloys. Then gaseous solution is air, liquid is wine and vinegar, and suspension is calamine lotion. You know calamine lotion? Have you all had chicken pox before?
Chicken pox.
Yeah. Have, yes. No, never. No. Oh, okay. Chicken pox. Never. Oh, when you have chicken pox, you gotta apply this.
They're very healthy.
Huh?
They're very healthy.
No, chicken pox. It's a virus, right? Okay, it's a very common one. I had it when I was in Sec 1, right? And it was and it was I got it from a friend, right? No, I'm not gonna switch that. Okay. So when you have chicken pox, you gotta apply this. Why? Because it's to prevent you from scratching yourself. When you scratch yourself, you get scar. Hmm? No, it's not Monaco. It's a cooling lotion.
There's people with chicken pox.
Yeah. Yeah.
I had that when I was K1.
You're K1. I was Sec 1, I remember. Sec 1. Yeah, it's very contagious, you know. Like if one person has it, right, then chances are a lot of the people. Right, the younger you have it, the better. Okay, so we're done. Okay. What's what? No, skip.
How about HFM?
And good mouth.
And go out, you know, like 1 month ago, you had it.
Okay, last one. Just do the last one today, okay? So study the two diagrams. Use the two diagrams to explain the difference between solution and suspension. So a solution does not have particles suspended in the liquid. Okay, you can see this. Diagram A, this is a solution. What?
Oh wow.
This is a solution, okay? And this is a suspension.
Mine don't have.
Okay, you can okay, right? So this is a suspension because you see these big pieces of stuff, right? So they cannot be dissolved, right? Like the bubble tea, right? This will be like the pearl. Okay. All right. So, yeah, that's all for today, right? Now I won't be going through the rest, right? Reason very simple. This is actually the second time I'm going through this, so it's some kind of a revision, okay? So next week, next week I might do a bit of revision again because based on whatever I have right here, see, it could be separation technique, animal composition. Well, let's find out, okay? The wheel is here to stay.
Yeah, that was coming.
Okay, bye-bye. See you. Bye-bye, Rosa. Bye-bye. She did. Yeah, before you were here. Yeah, we do elimination. Bye, see you. Then wheel. We're gonna do wheel next day. Okay, bye-bye. Yeah, elimination. Okay, now ready. Bye-bye. Bye-bye. Bye. See you. Goodbye.